Hello, my name is Ralf Schwedweger. I'm working for Soundtech in Göttingen, Germany, since more than 20 years. I have studied physics in the Third Institute for Physics, Sound and Vibration in Göttingen. Let us start with an overview about SiVision. You see here the SiVision started with the sound already loaded. And let me explain what we see in this window. The y-axis is a normal standard dB axis, while the x-axis is a logarithmic frequency axis. So in the moment we see here a screenshot, a shot of the sound at a certain time point. Here we see this green background this noisal component. That means in dB over frequency. And here we have some red lines. These red lines means that you hear the sound at this frequency as a tonal component. That means these tones can be perceived by the human ear in a separate way. So you will hear tones at this frequency. Here we have a small window for the readout, and the next tone close to my cursor is 117 Hertz, and here we have 154 Hertz, and so on. So, and what we see are these blue backgrounds, and these blue backgrounds are the ratings for the tonal components relative to the background noise. So that means the green noise is the background for these tones. And for example, here we see that this red line goes up almost to the third blue line. And here we see we have the score, so these blue lines are these ratings of these tones, how loud we can perceive these tones. And here we see this tone can be perceived with a rating of 3. Here we have another line that's coming out in dB much more, but this rating is not higher, because these blue lines are going here to low frequency, to higher values. So, or in other words, in low frequencies, the perception of tonal components is less dominant than in the mid-range or in the higher range. And for very high frequency, the perception of tonal components is getting less as well. So let us check here, for example, here we have in this window we see at this frequency very close to 80 Hertz. It's here the noise is at a level 53.6 dB, and the tones is at the level almost 67 dB. So that means the difference here is about 14 dB. That is a lot. But the score is 2.8. And here we have a tonal component that comes out only, let us look at the difference, 53 to 56.3. So it's about 3 dB. But this tonal component can be perceived by the human ear with the same dominance. So that means both tones have the same perception by the human ear. So now we have seen the background noise level, we have seen this tonal components, and the blue shapes are the ratings of these tonal components. And here we have another thing, we have here the shapes of this yellow background. And this yellow background means the modulations. So what are modulations? Modulations represents the time structure of the signal. So if there is no time structure, the modulations will be zero or at least very low. So normal noise will have almost no modulations if you have white or pink noise. And for technical sounds, you do have this kind of modulations. This gives a certain, let's say, color of the sound. So it's not easy to have an expression for this phenomena. Okay, let us start the playback just to have a short overview for this special sound. I already have prepared some different sounds, and at the letter A I have the sound of an aggregate. This is an aggregate in addition to an engine, and the sound was sent by a university to me, and I should rate it. So at about 10 seconds, you will hear a difference. So I will start the playback. So I hope you could hear the difference at about 10 seconds. The dominance of this aggregate that was switched off at 10 seconds, and the dominance of the sound, let's say the rattling, changes a lot. And if you check the yellow background changes in this frequency range and also about around 2 kilohertz. Here's 2 kilohertz, and here's from 4 to 10 kilohertz. It changes a lot. So let us start the playback again. Okay, I hope you have heard the difference when the aggregate was switched off at about 10 seconds. So I have focused on these modulations. The other components of the sound are also dominant, but these components does not change so much. So what changes are these yellow background, the modulations in the sound, and what we can do now that we can go to these modulations and we can add a filter to reduce these modulations. So let me say plus. So in the moment we have here a filter in this frequency range. These are this yellow and orange start and end point. We can see it here. The middle is 1 kilohertz, and it starts from 500 hertz and goes up to 1500 hertz. It works on the modulations, this filter, and here we have this filter curve, a broadband filter with a rather high slopes. So what I said, we should go to 4000 hertz and go to rather high frequencies. And maybe we can also add another filter at about 2 kilohertz. So first of all, we can reduce these modulations by putting this level down. So now it's minus 20 dB. And you see here it's minus 20. And this is the maximum of these filters that works. This is really a lot. 20 dB filtering is a world. So the change of these modulations is from a certain percentage. So modulations are given in a percentage of this noise background. And now we have scaled these modulations down to 20 dB. So first of all, we can have a subjective comparison. So let us focus at the time point when the aggregate is running. So at time 10 seconds it is switched off. And here let us start a little bit earlier range. Now the playback will done with all time. So let me put the filter on and off, and I hope you will hear the difference as well as you will see it while the background is going up and down, the yellow one. So I hope you have heard the difference, but we can put the lower frequency start here to a lower value. So let's go here, let's say from 800 Hertz. So these are the carrier frequencies of these modulations. Now it starts at about 758 Hertz and it goes up to 13 kilohertz. And let me now play back the signal, switch the filters on and off. So I hope you can hear the difference. The difference is much more prominent if you use a headphone, but you should also hear it with the ears of an expert, the difference of the sound.